All right, hi guys. Today we're going to take some more interparticle forces notes. Let's turn on this pen here and change the color. All right, so we're going to start by taking a look at what a meniscus is. And a meniscus is the curved surface of a liquid. So you can see that here, the water is curved. There's a glass tube down here that's been overfilled, and the water on top is curved. But it doesn't have to be curved up like this. Sometimes when water's in a container, like in a test tube, it will curve concave, or it could curve convex. And water is not the only material that does it. Mercury does it. Alcohol will do it. Just a property of materials. So what causes a meniscus to form? And the answer is obviously interparticle forces. That's why we're studying them. So in the picture above, you can see that the water is being curved because all the individual particles are actually holding on to each other. So if you took a look at like this water particle right there, why isn't it falling over the side? And the answer is because that water particle is being pulled inward by all the other water particles around it. Okay. So water can do this because it uses really strong hydrogen bonding to stay a liquid. If this pull right here was not very strong, then this surface would break and all the water would just pour down the sides of the tube. So if you were paying attention in biology, your biology teacher said that this was cohesion. But you're in a chemistry class this year, and we don't really use that terminology. We're going to ask, well, what causes cohesion? What's behind it? And cohesion is really just the attraction of water particles to themselves. And it happens because water can hydrogen bond. Okay. Now remember, in order to be able to hydrogen bond, well, let's see if I can draw with this thing. You have to have an H bonded to an F. Boom, like so. There's my bad H there. You have to have an O or an N, all bonded to H's. Whoa, that's kind of a crappy bond there, but we'll leave it. H, there we go. So I always say you need to have a phone if you are going to be able to hydrogen bond. So water can clearly hydrogen bond because it is H2O. It's got an H bonded to an O. That's bonded to another H. So you have H bonded to O. Okay. All right. So let's go back to that picture from earlier. How come the meniscus curves up sometimes and curves down other times? Like, what's going on there? So in order to do that, we have to talk about one more interparticle force, and that's called an ion-dipole interaction. So just like the name says, you need two things. You need a dipole, meaning the water, some part of the system has to be polar, and water is polar. It's got a negative side and a positive side. Remember that water, here's my H. I drew it I was kind of cheesy last time. Water is actually bent, right, like so. So water is polar because it's asymmetric. Let's go down here, change colors, right? If I drew a line right here, the top part of the water is different than the bottom part of the water. So it's asymmetric, meaning it's going to be polar. All right. Water can use dipole forces to hold other objects. And glass is made from a substance called sodium silicate. And that means that we have sodium ions and we have silicate ions stuck together. So we have the two combinations. We have a polar molecule and we have a bunch of ions. So we can have ion-dipole interactions. Oops, went ahead too fast there. Okay. Well, what are these ion-dipole forces? So in this picture up here, you see a sodium ion. Sodium, it's got a positive charge. This makes it an ion. And you've got water. Here's an H. Whoa. here's an O, here's another H, and let's see if I can draw tiny little things here. The H part of the water down here is positive, while the O part is negative. That's because the oxygen is pretty strong and it can pull electrons toward itself. So since it's got a negative side and a positive side, the negative side of the water is attracted to the positive ion. And the positive side of the water will be attracted to negative ions. So the silicate ions are negative, the water would spin the other way, and the positive side would actually attract to the negative ions. The other thing to keep in mind is that ion dipole forces are actually stronger than hydrogen bonds. So here's another way to look at it. In biology, your teacher said, oh, the reason that water climbs up the surface here is because of capillary action or adhesion. Those are two terms. But in chemistry, we don't really talk about that because we are interested in interparticle forces. So we're going to say, okay, adhesion, what is it? What causes it? And adhesion is what's caused by the water particles being more attracted to the ions. So let's just say like, oh, there's a positive ion right here. I'm going to, we'll simplify it. There's actually positives and negatives, but let's just say there's some positives that these water particles that are close, they're going to say, whoa, look at that. There's a positive ion up there, and they're going to be attracted to it, and they're going to pull away from their friends who are all trying to pull them downward. They're like the friends are saying, hey, come down here with us. But that positive ion is so attractive that the water will actually climb up the surface. Okay. So wait a minute. Why does mercury curve the other way? It looks like it's afraid of the glass. Like I just said, the water is climbing up because it's super attracted to the glass. Is the mercury actually trying to stay away? Is it like pulling away from that side? And the answer is no, not really. There's a separate explanation. The mercury atoms are actually more attracted to themselves than they are from the glass. Okay, mercury is just an atom. You can find it on the periodic table. It's number 80. I almost said number 40. It's just an atom. It is not polar, so it doesn't have a positive and negative side. So it's not attracted to the positive and negative ions in the glass. Actually, mercury is just attracted to other mercury because they can use London dispersion forces to attract themselves. So the mercury is not afraid of the glass. It's just more attracted to itself. So before, I told you that dispersion forces were the weakest forces. Then dipole were medium strength, hydrogen bonds were even stronger, and now we're going to add a new one, and we're going to say, ooh, there's also ion dipole interactions, which are even stronger. However, keep in mind that these are all super weak forces, right? It takes a while. You have to increase the force a lot to get to bonds. These are bonds. And covalent, polar covalent, and the strongest of all of them, the ionic bonds, are all much stronger than this. Okay. So we're going to use the ideas of adhesion and cohesion, but I want you to always explain them in terms of interparticle forces, right? You're not going to be able to just say, oh, this happens because of adhesion, because I'm going to ask you what's causing that adhesion, what causes the attraction.